This chapter we're going to be going over Venn diagrams and set operations. So starting with constructing Venn diagrams with two sets. So Venn diagrams are going to be used to illustrate a relationship between sets, and in a Venn diagram we use a rectangle, and this rectangle represents the universal set U, which you can see that that's right here for us. So everything of interest in whatever question we are currently doing is going to be in this rectangle representing the universal set. The items inside the rectangle, they can be divided into subsets of the universal set, which are going to be represented by circles. And you can see here that we have set A, subset A, represented by a circle inside of the universal set U. Okay, so usually this is going to come down when we're dealing with two sets. It's usually going to be broken down into 4 different cases. So let's go over them one by one. So let's call this one here case number 1. So this one, we have our rectangle for our universal set, and we have set A and set B. So this, when there's no overlap of set A and set B, this is called disjoint sets. So if A and B are disjoint sets, that means they have no elements in common, so there's no overlap among their subset circles. Okay, now taking a look at case 2 here, you can see in this one that that the subset A is also in the subset of B. So this time they are A is a subset of set B. So all elements of A are also in B. And we can obviously have this the other way where B is inside A. It would just be the reverse. B is a subset of A. Okay, let's see this next one now. So this next one is going to be, we'll call it case 3. And I made the circle purple because A was originally blue and B was originally red. So this means that they are just equal to each other, so they're right on top of each other, which is why I made it purple, because blue and red make purple. So in this case, this is equal sets. So set A equals set B, so they are right on top of each other. They have exactly the same elements. And the last case is probably the one that we're most used to seeing, is when there's this little overlap between the circles. So that's what we'll call this one. We'll call this one overlapping sets. So this one is used when sets A and B have something in common, and set A has elements that set B does not, and set B has elements that A does not. So let's go over let's go over these regions. There's 4 regions. So we're going to call this region 1, this overlap region 2, this region 3, and we'll call outside the circles region 4. Okay, so region 1 is going to represent elements that belong to A but not B. Okay, and then region 2 is going to represent the elements that they have in common, so which should make sense because that is the overlap. And region 3 is going to be elements in B but not in A. And lastly here for region 4, you'll notice that region 4 is outside of both of these circles, but it's still in the universal set. So that's exactly what it's going to represent. It's going to represent elements in the universal set, but not in the sets A or B. Okay, so these are the 4 cases that we can see. I'm just going to zoom out a little bit so we have them all on the same screen. So we have disjoint sets, subsets, equal sets, and overlapping sets. And like I mentioned, we're probably going to be dealing with overlapping sets the most. Okay, for the next thing that we're going to be doing is the complement of a set. So the definition for the complement of a set, the complement of set A is going to be symbolized with that little apostrophe. Sometimes you might see it with a superscript C representing complement. So the complement of set A is going to be the set of all elements that are in the universal set that are not in set A. So essentially it's everything in the universal set except for the elements in set A. Okay, so thinking about it in terms of the Venn diagram, it's going to be everything in the rectangle that is outside the circle. Okay, so it's everything that I kind of shaded in here that's outside the circle. And you could see down here, I labeled it right here, the complement of A, because A was the circle. So everything outside the circle of A. And then over here on the right, I just wrote it in set builder notation. So you would read this as, over here on the right, you would read this as the complement of A is the set of all elements X, such that X is in the universal set and X is not in set A. Okay, so let's do an example here. So let's say we have the universal set A, B, C, D, E, F, G, and we have set A, which is ACE, and we want to determine the complement of A, and we're going to illustrate the relationship using a Venn diagram. So we're looking for all of the elements in U that are not in A. So we have ACE in A, and we need to use everything except those in the universal. So that means we need B, D, F, and G. So that is our complement of A. We write it as a set, obviously, B, D, F, and G. Okay, so let's create a Venn diagram for this. So let's draw a rectangle. And this rectangle, as usual, represents the universal set. And let's have a circle in here. And that was a crappy circle. Let me redraw that. And good enough. So this is going to represent set A. So everything inside of set A, we had A, C, and E, right? So let's use red here. So we have A, C, and E inside of set A. And then outside of set A, but still in the universal set, are going to be B, D, F, G. So we can throw this right, we can throw this wherever we want. We can throw it right here, B, D, F, G. And these elements are going to represent, outside of the circle, that's going to represent the area where the complement goes. So I'm just going to label that a complement out here on the outside of the circle. Okay, so that is the Venn diagram for A and its complement inside the universal set represented by the rectangle. So now moving on to a couple other things, moving on to the intersection of sets. So the intersection of sets A and B, which is going to be symbolized by this symbol that can be called a cap. So let me write that down. So you can call that a cap. So the intersection A intersects B is going to be the set containing all of the elements that they have in common. So it's the elements that are in both of the sets. Okay, so when we're looking on the Venn diagram, it's actually going to be the portion where they overlap. So that's going to be this section in here. And I'm just going to label that A intersects B. Okay, intersection is where they overlap, so let's see some examples here. It's what they have in common. So given the universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the set A, which is 1, 2, 3, 8, B, which is 1, 3, 6, 7, 8, and C is the empty set, we want to find the following. So we're going to find A, for the first one here, A intersects B. So one way we can write this if we want, which I won't be writing it like this every time, but just know it can be seen like this, is you can replace A with its actual set, 1, 2, 3, 8, and intersects B, which is 1, 3, 6, 7, 8. So that's another way that you could possibly see these. So just keep that in mind. So we want to see what they have in common. So what they have in common here, they're going to have a 1 in common, they have a 3 in common, and they have an 8 in common. So that means that the intersection here is going to be the set. So make sure you write this as a set because it is a set. It's going to contain the elements 1, 3, 8. So that is the intersection of A and B. Okay, next one, let's say we have A intersects C. So this time I won't write it out like I just had it written out. I guess I'll keep writing it out this way. So let's do A, which is 1, 2, 3, 8, and C, which is the empty set. So we want to see what these elements have in common. So there's actually no elements that these have in common, right? So since there's no elements that they have in common, we can actually just rewrite the empty set because that represents no elements. So you can write it like that, or you can write it like this. Okay, and then for the next one, we have A complement intersects B. So first we have to figure out what A complement is. So A complement is going to be all of the elements in U that are not in A. So 1, 2, 3, 8, 1, 2, 3, 8. So it's everything in the universal set other than 1, 2, 3, 8. So that's going to leave us with 4, 5, 6, 7, 9, 10. That is A complement. We want to see the intersection between that and B. B was 1, 3, 6, 7, 8. So we need to see what they have in common here, and we can do that by doing it the way we just did it. They both have a 7. They both have a 6, and I believe that is all. So the intersection is going to be the set 6, 7. Okay, let me just space these out a little bit for us. Okay, so I just had to give us some space. I was getting a little crowded. And let's do this last one. So we have A intersects B, and then we're taking the complement. So anytime you have parentheses, you need to do what's inside the parentheses first, and then do what's outside the parentheses. So let's write this like this. I'm going to put a big parentheses around it, and then we're going to write out A. So we know that A intersects B is 1, 3, 8. So that's going to be 1, 3, 8. And we know that because that is from part A. So that is the first one that we did. If we didn't know it, we would have to go through and actually find the intersection first. So we can actually get rid of these parentheses. So all we're doing now is finding the complement of that intersection. Okay, so what we need to do now is find all the elements in set U, in the universal set, except for 1, 3, 8. So going back up to the universal set, we're going to choose everything except for 1, 3, and 8. And that's going to leave us with 2, 4, 5, 6, 7, 9, 10. Okay, so that was 2, 4, 5, 6, 7, and 9, 10. So always do what is inside parentheses first. In this case, we just so happen to already have that done, so we didn't actually have to go through and do it. And once we found that set, we took the complement of it by using the universal set. Okay, so for the next thing here, we have the union of sets. So the union of sets A and B is going to be symbolized with this symbol that looks conveniently like a U. So that's how you can remember it's that symbol. It looks like a U. And you can actually call this, you can call it union, you can call it a U, or you can call it a cup. Okay, so it looks like a U, U for union. It's going to be the set containing all of the elements of set A or set B, or both sets. So if we are looking at this Venn diagram here, the union is going to be essentially what is in all of these circles. In this case, 2 of them. So it's in all both of these circles completely combined. So it's hard to, I don't want to say the word both, because when you say both, it's kind of implying the overlap, not the whole thing. So union, you should think the whole thing. When you think of the word union, it kind of means to join things together. So you're joining all of the circles together and getting everything. For intersection, you should be thinking, for example, where roads intersect. It's where they're crossing paths. It's where they meet, where they are overlapping. So intersection is overlapping. Union is joining, meaning everything. Okay, and then the way that we would read this in set builder notation, which is over here on the right, is A union B is going to be the set of all elements X, such that X is an element of A, or X is an element of B. So the word or is kind of like an inclusive or, meaning everything this time. Oops. Okay, so let's do an example here. And let me just space out these examples. Okay, so we have the universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have set A, which is 1, 2, 4, 6. Set B, 1, 3, 6, 7, 9. And for the first one, we want to find the union A union B. So A union B, we are taking everything from A and B. And we're joining them for one big set. So set A is 1, 2, 4, 6. You don't have to write out this kind of intermediate step here if you don't want to. Union set B, which is 1, 3, 6, 7, 9. So we're taking everything from it. And let's write these in order. And remember, don't write an element more than once. So we have 1 in both of them. And then we have a 2 in set A. We have a 3 in set B. 4 in set A. We have a 6 in both of them. And then a 7 and 9 in set B. So you're just rewriting everything in these sets into one big set without writing an element twice. Okay, for the next thing we have A union C. So let's write this out. That's going to be 1, 2, 4, 6. And that's going to be union the empty set again. So C is the empty set. So when we're trying to take the union of this, we are combining these into one big set with everything from A and from set C. And to do that, set A is 1, 2, 4, 6. Set C is the empty set, so we don't need to write anything for it. So the union between them is just everything from set A, because set C could not give anything to that union set. So anytime you have a set and you have the union, the empty set, so A union C in this case just equaled A. If you have a union with the empty set, it just equals the other set. Okay, and for the next one, we have the complement of A union B. So let's find the complement of A. Let's go up to the beginning of the problem. So the complement of A is going to be everything in the universal set other than the elements in A. So everything except for 1, 2, 4, 6, which is going to leave us with 3, 5, 7, 8, 9, 10. So that's going to be 3, 5, 7, 8, 9, 10. That is the complement of A, and we're going to union that with B. And set B is 1, 3, 6, 7, 9. So now we're joining these sets together in one big set, and let's go in order. So set B has a 1. They both have a 3. Set A complement has a 5. Set B has a 6. They both have a 7. A complement has an 8. They both have a 9. A complement has a 10. So 1, 3, 5, 6, 7, 8, 9, 10 are the elements in the set for A complement union B. Okay, last one for this, we have A union B, and then we're going to take the complement of it. So once again, we have to do A union B. We actually already did that in part A again. So A union B is right up here. So let's just write that down. Okay, so now we're going to be doing the complement of this set. So the complement of 1, 2, 3, 4, 6, 7, 9. So put the little apostrophe representing the complement. So it's going to be everything in the universal set other than those numbers. So it's everything up here in this universal set except for those numbers, which were 1, 2, 3, 4, 6, 7, 9, and that's going to be 5, 8, and 10. So that means this answer is the set that contains the elements 5, 8, and 10. Okay, so let's do something similar, except let's use a Venn diagram to do some examples. So we have this Venn diagram. We have the universal set represented by the rectangle. We have the overlapping sets A and B. And then we have these elements that are in different parts of the overlapping sets here. Okay, so let's use this to answer these questions. So the first one is find the set for the universal set. Find capital U, which is the universal set. So U is going to be everything in that rectangle. So these are all going to be sets. Make sure you have the braces around them. So U is going to be 8, N. So I'm going to be a little bit unorganized and kind of go out of any sort of order here. I'm just going to go with what is outside of the circles, so 8N, and now I'm going to go with what's inside A, but not in B, so 9T. Now I'm going to go with the overlap, SC, and now I'm going to go with what's in B, but not A, 3Q7. So this represents the universal set, every single element in that rectangle. Next, let's find all of the elements of A. So all of the elements of A, that's going to be everything in a circle. So it doesn't mean only A, it just means everything in all of A. Okay, so that's going to be 9, T, S, and C. So that includes the overlap. Okay, and now for B. For B, that's going to be 3Q7 as well as the overlap, because once again, the overlap is part of circle B. And now let's find B complement. So B complement is going to be everything that is not in circle B. So that's going to be everything that's not covered by this highlighter. So when we do it like that, that's probably pretty easy. Everything not in B is going to be 8, N, 9, and T. So that's the complement of B. And now for the intersection. So we want 8 intersect B, so we have to know what these symbols mean because they don't give us a hint here. So we have to know that that means intersection. So intersection we have to know is the overlap. So the overlap is right here, and the elements in the overlap are elements C and S. So this set is going to be S, C. And for the next one, we have the union A union B. So we have to remember for union that it's everything in these circles. So it is all of those elements. So I can't fit them on the same screen here. Let's see, we have 9TSC. So that's the set 9TSC. And then it's going to be, I believe it was 3Q7. Okay, so it was everything in those circles combined into one. And now we're going to do the complement of that union that we just found, the complement of A union B. So it's going to be everything that is not in those circles. So what that means, it's going to be everything except for what I'm highlighting, which is just going to be the 8 and the n. So this complement is just 8, n. And for the last one, we have cardinality. So remember that the n out front like this represents the cardinal number. So we want the cardinality of A union B. So our answer is going to be a number here. This is not a set. So it's the cardinality of the union. So that's going to be how many elements are inside the circles. Well, we have to count them. 1, 2, 3, 4, 5, 6, and 7. So there are 7 elements in here. So our answer is 7. Okay, so let's do another example, make it a little bit more difficult. So we have the universal set, which consists of the elements A, B, C, D, E, F, G. We have set A, which consists of the elements A, B, E, G. B, which contains A, C, D, E. And C, which contains B, E, F. So for the first one, we're finding overall a intersection. But then before we find that, we have to find the union of A and B. And then we also have to find the union of A and C. And then we're going to find the intersection of both of those new sets. Okay, so for the union of A and B here, so union is just going to be all of the elements in these combined. So A and B both have a A. A has a B. Both sets have set B has a D. Set A and B both have an E. And set A has a G. So it is everything from the sets combined into one set without repeating any of the elements. Oh, and it looks like set B also had a C in here, so let me just erase that. So it was A, B, C, D, E, and G. Okay, so now we need to find the union of set A and set C. That's going to be the second one here. So set A and set C. A has an A in it. They both have a B in it. They both have an E in it. Set C has an F in it. And set A has a G in it. So the union of sets A and C is going to be A, B, E, F, G. So now we need to find the intersection of these sets. So we're trying to find what do these two sets have in common this time. So they both have an A in common. They both have a B in common. They have an E in common. And they have a G in common. So that's going to be our intersection. That's going to be our answer. It's the set with the elements A, B, E, and G. Okay, so when you have more than one operation, you just have to do whatever's in the parentheses first once again, and then go from there. For the next one, we have another intersection question, except first we have to find the union of A and B, and then we have to find the complement of C. So let's find the union of A and B, and we actually already found that from part A here. So it's the same question as what we just did. So let's just steal that from there. So it's going to be this one up here. It's going to be the set A, B, C, D, E, G. And that's going to be the intersection with the complement of C. So we do have to find the complement of C. The complement of C is going to be everything in the universal set that is not in set C. So it's everything other than B, E, F, which is going to be A, C, D, G. So that's going to be the complement A, C, D, G. And now we have to find the intersection of these two sets. So intersection meaning what they have in common. They both have an A, they both have a C, they both have a D, and they both have a G. So the intersection between these sets is going to be the elements A, C, D, and G. Okay, and now for the last one, we have the complement of A union the complement of B. Let's actually change this to, we'll do an intersection one here. Let's change this to A intersects B. So for the complements. So we're going to find the intersection of A complement with B complement. So let's find A complement first before doing this intersection. So A complement is going to be everything in the universal set except for what's in set A. So the elements in set A are A, B, E, G. So everything except for A, B, E, G leaves us with C, D, F. So the complement of A is C, D, F. And now we need to find the complement of B. So going back up here, complement of B is everything in the universal set other than what's in B. So it's everything other than A, C, D, E, which leaves us with B, F, G. So that's going to be B, F, G for the complement of B. And now we're finding the intersection of these, so we're finding what they have in common. And it looks like they only have an F in common. So the answer here is going to be the set with just an F in it. Okay, now for the next thing, we're going to go over the meaning of the words and or. So the word and is generally used to mean intersection, which we mentioned. So and you can also think of it as the word both. And the word or is going to be thought of to mean union. So and both means intersection, or either or is going to mean union. Okay, so this is going to bring us to this little formula here. And this formula is going to go over the relationship between the cardinality of the union between sets, the cardinality of one set, and the cardinality of the other set, and the cardinality of the intersection of the sets. Okay, so taking a look at this, it is the cardinality, or the number of elements in the union, is going to equal the number of elements in A plus the number of elements in B minus the number of elements in the intersection. So what this means, the thing that we're looking for, the thing that's solved for on the left, is going to be the cardinality, the number of elements of the union. The number of elements of the union represents both circles shaded in. So we're looking to see how many elements are in this both of these circles shaded in. So it's probably pretty clear that it's going to equal the circle of A plus the circle of B. However, when we add those together, this middle portion gets added twice. and that is the intersection between them. So since we accidentally added this twice, we have to subtract one off. So that's why we have this subtraction of the intersection here. Okay, so to find the whole thing, we add both of them separately, and then we subtract off the intersection because we added it in twice. Okay, so let's do a couple examples using this little formula here. So the results of a survey of visitors at the Grand Canyon showed that 25 speak Spanish, 14 speak French, and 4 speak both Spanish and French. We want to know how many speak Spanish or French. Okay, so let's set up this formula here. So the number of elements in the union equals the number of elements of A plus number of elements of B minus the number of elements common to both of them. So what we're going to have to do is let A and B equal something here. So let's let A be the number of visitors who speak Spanish, and B is going to be the number of visitors that speak French. Okay, so let's see what's given to us in the problem here. So we have 25 speak Spanish. So 25 speak Spanish. What that means, that's going to be the cardinality of set A, because that's what we let A equal. And 14 speak French. That's going to be the cardinality of set B, because that's what we chose B to equal. And 4 speak both Spanish and French. So we know that this is going to be the intersection because of the word and here. So it's going to be the cardinality of A intersects B. Okay, so once again, that's because of the word and. That tells us it's the intersection. So we are solving for the left-hand side of the equation here, which is nice because it's already solved for. So we're solving for the union. And we also knew we were solving for the union because that's in the question. It says how many speak Spanish or French, which means cardinality of the union. So let's plug in all these values. So the cardinality of A is 25, plus the cardinality of B, which is 14, minus the cardinality of both, which is 4. So all we have to do is just add 25 plus 14 minus 4, and this is going to give us 35. So we should have a conclusion for our answer here. So 35 of the visitors surveyed speak Spanish or French. Let's do another example here. So the results of a survey of customers at a McDonald's restaurant showed that 28 purchased either a hamburger or French fries, 20 purchased French fries, and 17 purchased both a hamburger and French fries. We want to know how many customers purchased only a hamburger. So let's write down the formula. And let's let our variables A and B both represent something here. So A, let's say A is going to be the set of customers who purchased a hamburger. And that's going to leave us with set B. It's going to be the set of customers, in this case, like the number of customers that purchased French fries. So let's take a look at what we are given in the problem here. So we have the first number, 28. 28 purchased either a hamburger or French fries. So the word or should tell us that that's going to be a union. And 20 purchased French fries. So French fries we said was set B. So that's going to be the cardinality of set B. And 17 purchased both a hamburger and French fries. So we see the words both and that's going to tell us that that's going to be the intersection, the cardinality of the intersection of A and B. And we are looking for how many customers purchased only a hamburger. So only a hamburger, that is set A. which is what we're going to be looking for here. So we're looking for the cardinality of A this time. Okay, so let's plug in all of our values. So the cardinality of the union is going to be 28. The cardinality of set A is going to be what we're looking for, so I'm going to leave that as cardinality of A, plus the cardinality of B is French fries, that's 20, minus the cardinality of their intersection, and their intersection is going to be the 17. So technically this is a linear equation here. The way that we solve this, n of A is going to represent kind of like our variable that we're solving for. So on the right hand side, we first have to simplify. 20 minus 17 gives us 3. And in order to get the cardinality of A by itself, we have to get this 3 to the other side of the equation. And in order to do that, we have to do the opposite sign, which means we have to subtract it. So 28 minus 3 is 25. So we get 25 equals the cardinality of A. So this means that 25 customers purchased only a hamburger. Or not only a hamburger, but they purchased a hamburger. So technically this wording up here in the question should just say purchased a hamburger. Okay, we have two more things to go over here. So the next thing is going to be the difference of two sets. So the difference of two sets, we should be thinking about subtraction here, is going to be symbolized as A minus B, set A minus set B. It's going to be the set of elements that belong to set A, but not to set B. So you can think of it as you're starting with A and you're subtracting off the elements of B. So what this is going to be in a Venn diagram is going to be represented by the circle for set A, but not the overlap. So over here on the right, we can see that A minus B is the same thing as the intersection of A and B complement. And in set builder notation, it can be read as the set of all elements X, such that X is in A and X is not in B. Okay, so let's do an example here. So given the universal set A, B, C, D, E, F, G, H, I, J, K, and we have the set A, which is B, D, E, F, G, H, set B, which is A, B, D, H, I, and set C, which is B, E, G, and we want to find the following. For part A here, we want to find A minus B. So instead of having to set this up like we were doing it before, let's just think about these ones logically. What this represents, what we set up here, it's going to be all of the elements in set A, but not set B. So it's going to be all of these elements in set A, but we're going to have to get rid of the ones that are in set B. So we have to get rid of an A. There's no A in set A, so we don't have to worry about it. We have to get rid of a B. We have to get rid of a D. We have to get rid of an H. And lastly, there is no I in set A, so we don't have to worry about that one. So A minus B, all of the elements in A that are not in B, this is going to give us what's remaining from what we crossed out. That's going to give us E, F, G. So we started with A, we subtracted away the elements from B, and we're left with E, F, G. Okay, and now for this next one here, we have A minus C. So once again, we are starting with the elements of A, and we're subtracting off the elements of C. So that means we are subtracting off the elements B, E, G. So let's cross those out, B, E, G. And whatever's left over is going to be our set A minus C. So we're left with D, F, H. And that is our answer for that one. And now let's make these a little bit more complicated here. We're going to have A complement minus B. So first we have to find A complement. So let's write A complement. Let's just write it right up here. So A complement is going to be everything in the universal set that's not in set A. So it's going to be everything other than B, D, E, F, G, H. So all of those were from set A. So the complement is going to be A, C, I, J, K. Okay, so that is the complement of A. Once we have that written down, we can actually do this the same way that we just did it. So it's going to be all of the elements from the complement of A, subtracting off the elements from B. So in B, we have to subtract off A, B, D, H, I. So we have to subtract off A and I are the only ones that are here. So that means what we have after we subtract those off are going to be the elements in the set C, J, K. Okay, and now doing one more here, we have the set A minus C complement. So we're starting with A and we're subtracting off the elements from C complement, which means we need to find C complement. So C complement is going to be everything in set C, everything in the universal set that's not in set C. So that means we need to get rid of B, E, G. So that means C complement is going to be A, C, D, F, H, I, J, K. Okay, so that's going to be the complement of C. So now what we're going to be doing is we're going to be starting, so it's A minus C complement. So we're going to be starting with set A, and we're going to be subtracting off all of the elements from C complement. So C complement is ACD, so A only has the D, and then FHI, so F and H, and then JK. So set A does not have J or K, so we are done. So it's whatever's left over, which is BEG. So A minus C complement, the set is BEG. Okay, so that is the difference between two sets. You don't have to do anything too crazy, you just can think about it logically by subtracting off the elements of one set from the other one. Okay, for the last thing is the Cartesian product. So the Cartesian product of set A and set B is going to be symbolized by this times symbol, and we're going to read this as A cross B. It's going to be the set of all possible ordered pairs, and we're going to have ordered pairs in the form A comma B. So ordered pairs are always in parentheses, so it's a set of all possible ordered pairs where A is from set A and B is from set B. So that means the first element in the ordered pair is from the first set in the Cartesian product, and the second element in the ordered pair is from the second set in the Cartesian product. So the way we can do this to make it a little bit easier on ourselves here is going to be select the first element of set A, and then we're going to form an ordered pair with each element in set B. Then we're going to select the second element of set A and form an ordered pair with each element of set B, and then we're going to keep on going in that manner until we use up every element of set A. So let's see an example here so that makes sense. So suppose we have set A, which is orange, banana, apple, and set B has the elements 1 and 2. And for the first one, we want to determine A cross B, the Cartesian product of A cross B. So what we're going to do here is we're going to represent this with a set. So our answer is still going to be a set. It's a set of ordered pairs. So each element is going to be an ordered pair. The first ordered pair, so recognize that A is first here. That is important. The first ordered pair, we're going to start with orange, and then we're going to create an ordered pair with orange with each element from set B. So we can have orange, comma, 1. That's our first ordered pair. Our second one is going to be orange, comma, 2. Okay, so we took the first element from the first set and we gave it to each element in the second set. So now let's do it again and just go left to right, and now let's go to the next one, which is banana. So we're going to give banana from the first set into each element in the second set. So the ordered pair is going to be banana, comma 1, and then it's going to be banana, comma 2. Okay, and then lastly we have apple for the first one. So we do the same thing. We're going to have apple, comma 1, and then lastly apple, comma 2. Okay, so let me just rewrite this so it's all on one line here. Okay, so there we go. It's a little bit more organized. So for the next one, for example B here, we have B cross A. So it looks like the same thing, but it's going to turn out it's not going to be exactly the same. So this time we're starting with B, and that's going to be the first element in the ordered pair, and then we're going to go to A, which is going to be the second element. We're going to do the same concept though. We're going to start with the first element of B, which is a 1, and we're going to give it to each element in the set A. So it's going to be 1, comma orange. That's the first one. Then it's going to be 1, comma banana. That's the second ordered pair. The third one's going to be 1, comma apple. And now we have to move to the second one in set B. So it's going to be 2, comma orange. And then 2, comma banana. And for the last one, it's going to be 2, comma apple. So you can see that these are pretty much almost the same thing, except it's essentially completely flip-flopped for the ordered pairs. Okay, next we're going to do A cross A. So we're crossing A with itself here. So for this one, we're going to start with the element of A, and then we're going to give it each element from itself. So we're going to kind of imagine that there's 2 set A's that we're going to be using, and we're going to be doing the same thing that we just did. So for set A, we're going to start with the one on the left, which is orange, and that's going to be the first element in the ordered pair. And then we're going to actually give it itself here. So let me write down set A again. Okay, so we're starting with orange, and now we're going to give it orange from the other set A. So this is going to be the first ordered pair, orange, comma orange. And the second one is going to be orange, comma banana for the second one. And the third one is going to be orange, comma apple. And what I'm going to do now is I'm going to fill in the rest of it myself. I'll pause the video and fill it in. So what we would do next is we would go to banana and then give banana each one from the second one. So banana orange, banana banana, banana apple. And then we would go to apple and do the same thing. Apple orange, apple banana, apple apple. So let me just go ahead and fill this in for time's sake. So we should end up with all of these ordered pairs, and it looks like there's 9 ordered pairs here. Okay, for the last one we have B cross B. So for B cross B, we're going to do something similar to what we just did. Let's rewrite B. So I'm going to rewrite B up here, right below itself, and we're going to give the first, we're going to start with the first one in the first B, which is 1, and then we're going to give it each element in the second one. So it's going to start with 1, comma 1. So 1, comma 1 for the first one, and then the second one is going to be 1, comma 2 for the second ordered pair, and then you probably can see what the next ones are going to be here. And then we're going to go to the next one, which is 2 from the first B set that we have. Then this one's going to be b comma 1 and then 2 comma 1 and 2 comma 2. So let me just fill those in, 2 comma 1 and 2 comma 2. So these would be the only ordered pairs for B cross B. Okay, so that is it for chapter 2.3.